abstraction. So functional abstraction is giving a name to some computational process and then referring to that process as a whole without worrying about its implementation details. So here's a function square, and here's another function, sum squares, that calls square in its body. And the question is, what does sum squares really need to know about square in order to use it correctly? So for each of these, try to answer it yourself before I show you my opinion. Does sum squares need to know that square takes exactly one argument? Yes, it does. Otherwise, it can't call it. Does it need to know that square has the intrinsic name square? No. An intrinsic name is only there so that humans can inspect the name of a function. Any function with any intrinsic name, as long as it's bound to the name square in the current environment, will suffice. Do we need to know the behavior of square, that it computes the square of a number? Yes. In order to use a functional abstraction effectively, you need to know what it's supposed to do, its behavior. Do we need to know that square computes square by calling the mul function? No. It can compute the square any way it wants, and will still have a correct implementation of sum squares, which relies on square. So we could compute square like this, with the built-in pow function, or I could invent some strange way of computing squares, such as this. If the name square were bound to a built-in function, in fact, then sum squares would still work identically. It doesn't matter whether a square is user-defined or built-in for sum squares to use it. Now let's talk a little bit about choosing names. Names are there to help people. So names that you choose typically don't matter for the correctness of a program, but they do matter a lot for composition, or for how you write your program in such a way that other humans can read it. So here are some guidelines. Names should try to convey the meaning or the purpose of a value to which they are bound, so that it's easy to see why we've created this value and what we're going to do with it next. The type of the value bound to the name, whether it's a number or a string, is best documented in a function's docstring, as opposed to the name that you bind to the value itself. And function names, the names that we give to our functions that we define, typically convey either their effect, such as printing, their behavior, such as tripling, or the value returned, the absolute value of a number. All of these are reasonable ways to name a function. So here are just some suggestions. The stuff on the left, not such a good idea. The stuff on the right is preferred. Instead of calling some value true-false, just because it's either true or false, try to say what it's supposed to represent, such as the fact that a player rolled a 1 in the game of Hog. Instead of just single letters, such as D, in a context of a larger program, it's very helpful to use a whole name, such as dice. When you're naming a function, you can describe what that function does, what its behavior is, as opposed to just who calls it. So when you're defining play, we had a functional abstraction for taking an individual turn, and instead of calling it play helper or play subfunction, just because it was called by play, we called it take turn because that's what it does. It simulates taking a turn. And then, not just play, but some other function could use it as well. We don't want to name values just by their type. So instead of my int to say that something's an integer, we want to say what the purpose of storing that integer is and what it represents. The number of rolls, for instance. And finally, there are some names that are just extremely hard to read depending on your font, such as the lowercase l, the capital I, the capital O, can be confused for numbers 1 and 0. It's much more typical, if you're going to use just a single letter, to use something else, like K, I, or M. And then you have to wonder about which values deserve a name at all. We don't have to give every intermediate value in our program a name because we can have compound expressions. But if you have the same repeated compound expression over and over again, it's often better to give it a name. That way, if you want to change it, it will change everywhere. So if I write something like this, where I've computed the square root of a squared plus b squared, both in a conditional statement and in the assignment statement in the suite, it's probably better to give that thing a name and then use it twice, here and there. So that if we need to change how we compute the hypotenuse in some way, we can do that all in one place. So don't repeat yourself, and also don't make your expressions too complex, so complex that it's hard for a human to read them. Even though a computer has no problem with this long line, it can take a human quite some time to understand what's going on. It might be better to pull out some meaningful subpart of it, such as the discriminant of this quadratic formula, and give that a name so that both this equation and this equation are easier to read for a human than trying to understand this whole nested thing. I have a couple more naming tips. Names can be long, that's okay, especially if they help you document what your code does. So an assignment statement that takes the average of the age of some students and calls that the average age is a fine way to explain what's going on, because it's kind of clear what every piece of this is going to do. And I think that's preferable to including a comment about what is going on, and then a more cryptic expression. And finally, I think it's okay if names are short, even single letters, if they're representing generic quantities, such as you can take the absolute value of any real number, or you're using just a count, or an argument to a mathematical operation, or you're wrapping some generic function. But there are conventions that are worth learning because programmers use them in many different programming languages. Certain letters are used to represent integers, others often represent real numbers, and others are used to represent functions. These are all just practical guidelines. You don't have to memorize them all. You don't even have to obey them. Writing programs is a creative act, and if you want to do something else, that's fine, as long as your program is understandable by other people. So having conventions makes everybody understand a little bit better.